literally baffled an entire facility. We are talking about finished product contamination. Yeah, the absolute worst case scenario for any manufacturing plant, right? But this case study isn't just a crazy story. It is a masterclass in why we have to look way beyond the obvious when troubleshooting. It involves a super stubborn microbe we're affectionately calling Pathogen Sally, a really frustrating string of test results, and a structural flaw so tiny it was practically invisible to the naked eye. So let's get into it and see exactly how this mystery unfolded. So, where was Pathogen Sally actually hiding? Well, our story kicks off with that dreaded phone call. Routine finished product testing suddenly popped a positive result for Pathogen Sally. And look, as you can imagine, when a pathogen actually makes it all the way into the finished product, alarm bells are ringing loudly. It sparks this immediate, frantic root cause investigation by the facility's food safety teams. Their priority? Crystal clear. Find the source of the contamination and eliminate it before a single additional product leaves the building. But as the teams quickly figured out, finding Sally wasn't going to be a walk in the park. She was incredibly elusive, and standard visual inspections, they were turning up absolutely zero. They realized they had to systematically dismantle the plant's environment, literally data point by data point. To track down this invisible threat, the food safety teams deployed a highly structured three-step testing procedure. This wasn't just them throwing darts at a board. It was a highly calculated net they cast over the entire production process. Step 1 involved swabbing the equipment right before the sanitation crew even came in. Step 2 was swabbing immediately after sanitation was complete. And Step 3, which, spoiler alert, ended up being absolutely critical, involved taking swabs at specific targeted intervals while the plant was actively running in production. By looking at these three distinct phases, the team hoped to isolate exactly when and where the contamination was sneaking its way into the product stream. To pull off this massive testing protocol, they obviously needed the right tools. And this brilliantly illustrates the real workhorse of environmental monitoring, the generic sponge swab. This is the absolute go-to tool used by food safety professionals to cover broad expanses of the factory. I mean, when you're dealing with giant stainless steel panels, super wide conveyor belts, or the vast interiors of mixing tanks, you need a swab that can physically pick up microbes over a really big surface area. The teams went through hundreds of these things, methodically wiping down the obvious product contact zones and the surrounding environment just to build out their data map. But you know as well as I do, industrial food processing equipment is incredibly complex. It is literally full of nooks, crannies, bolts, hinges, you name it. So when the target area got way too tight or awkward for those larger, generic sponge swabs, the food safety teams had to pivot. They switched tactics and moved to Q-tip-style swabs. Think of these as the precision instruments of the swabbing world. They allow the investigators to get deep into narrow crevices, threaded areas, and those really tight corners where moisture and product like to hide, but a bulky sponge just can't physically reach. By using both tools in tandem, they made sure no surface, big or small, was left untested. Okay, so the initial results start rolling in, and whoa, they find a massive spike right out of the gate. Out of the batch of swabs taken during Step 1, and remember that is before sanitation, a staggering 100 swabs came back positive for Pathogen Sally. Now, I know that number sounds absolutely terrifying, but it actually just provided a baseline for the team. Because these swabs were taken before the cleaning crew even touched the line, these positive results were, well, kind of expected. The equipment had been in direct contact with the product, so naturally the pathogen was going to be there. It confirmed Pathogen Sally was definitely in the building, but the real test was what was going to happen next. And this is where the data revealed a seriously perplexing paradox. After the intense sanitation process, the swabs came back completely negative. Honestly, the cleaning crew was doing a fantastic job, the chemicals were doing their thing, and the surfaces were effectively sanitized. But as soon as the plant resumed production and the heavy equipment started vibrating and shaking, swabs taken during those runtime intervals started popping positive again. It was wild. The pathogen was somehow returning mid-run, literally recontaminating the exact same surfaces that had just been proven totally clean. So you have to ask yourself, how on earth could the pathogen survive the cleaning process? This baffling clue totally flipped the trajectory of the whole investigation. If the surfaces were verifiably clean after sanitation, where was Pathogen Sally coming from the second the machines turned back on? The food safety teams had a major light bulb moment. They realized they weren't just dealing with something sitting on the surface. Nope, it was protected. It was hiding from those harsh cleaning chemicals, surviving the entire sanitation cycle untouched, and only coming out to play once the line was active. This realization forced the team to zoom out and build a completely new suspect list. The team started looking up. They specifically examined the areas suspended directly above the primary food contact surfaces. And that is when they zeroed in on their prime suspect, a hollow structural framework. This specific frame was responsible for holding a liquid addition tank directly above the main mixer. But what really caught their eye was that this framework had clearly been patched up or modified multiple times over the years. It had several very rough, just plain ugly exterior welds. And because it sat directly above the open mixer, well, any contamination dripping from this frame was going to take a one-way trip straight into the product stream. They went ahead and swabbed the exterior of this hollow framework during production and, boom, positive for pathogen Sally. So, the team came up with an initial theory based on what they could visually see. They figured, okay, the exterior weld is simply too rough, too porous, and inherently uncleanable. They assumed the pathogen was just clinging to the microscopic ridges and little pits on the outside of that messy weld, which let it survive the cleaning process and then drip down when things got moving. It made total logical sense. And based on that working theory, management made the decisive call to just completely cut out the offending welded section and replace it with a newly fabricated framework. So the crucial point is what happened next. The maintenance team brings in the heavy tools, right? They physically slice right through that hollow metal tube to remove the section with the rough welds. And as soon as that metal parted, the true root cause finally revealed itself. It wasn't just the outside of the weld that was the problem. The team watched in absolute horror as a pool of stagnant, incredibly nasty liquid came pouring directly out of the hollow interior of the framework. Ugh, just thinking about it, right? They immediately grabbed a sample of this trapped fluid and rushed it straight to the lab for testing. The results were completely conclusive. That liquid was absolutely teeming with pathogen Sally. So how did this actually happen? Well, it is a textbook failure of structural integrity. Step 1, those poor repeated welds didn't just look bad on the outside. They had actually developed microscopic cracks that went all the way through the metal casing. Step 2, over months and months of normal operation, the daily washdowns, water, cleaning solutions, and even tiny particles of food product were essentially sucked inside the hollow tube through those microcracks. It's a mix of capillary action and temperature changes pulling it right in. Step 3, once it was inside that dark, protected hollow frame, that mix created the perfect, undisturbed harborage point. The pathogen thrived in there, totally safe from the sanitation crew. Then, during production, the everyday vibration of the machinery would literally shake this contaminated soup right back out through those exact same microcracks, dripping directly into the mixer below. The ultimate lesson from the mystery of pathogen Sally is super profound, and honestly, it is the key takeaway I want you to grab from this explainer. We absolutely must prioritize hygienic design right from the ground up. Listen, you can have the most expensive sanitation chemicals and the most dedicated, hardworking cleaning crews in the entire world, but if your equipment is fundamentally flawed, you are fighting a losing battle. Hygienic design means anticipating exactly where water and product can get trapped. It means recognizing that hollow tubing, especially anywhere near food contact zones, represents a massive, inherent risk if it is not 100% continuously sealed and regularly inspected. So how do we actually apply this in the real world? Well, here are some actionable steps for your food safety teams. First, when you're investigating an issue, you have to look way past the obvious. Don't just settle for surface swabbing. Rigorously examine the actual hygienic design of the equipment itself. And here's a big one. If you have legacy hollow frames in your facility, and let's be real, almost everybody does, there is a highly effective proactive technique you can use. You can safely drill a small weep hole at the absolute lowest point of that hollow frame. If there's liquid accumulation trapped inside, it will immediately drain out. And if fluid does come out, be ready to collect that sample on the spot and get it tested immediately. Which brings us to the end of our explainer today, and I really want to leave you with a question to chew on. Think about the manufacturing lines you manage, operate, or audit on a daily basis. Think about the frameworks holding up those tanks, the conveyors, the overhead walkways. Are your hollow frames harboring a secret right now? Could years of washdowns and tiny microcracks have created a perfect, cozy home for a pathogen just waiting to drip out during production? Hey, don't wait for finished product contamination to find out. Take the lessons of pathogen Sally, look really closely at your hygienic design, and get proactive with your investigations. Thank you so much for joining me to walk through this incredible case study. Keep asking those tough questions, and I'll catch you on the next explainer.